Let us look at some changes that take place in our surroundings every day. 1. The curdling of milk, which happens within few hours, especially during summer. 2. The rice batter, which we keep overnight for making lip-smacking idlis and dosas, becomes a bit sour during summer by the process of fermentation. 3. Milk is changed to yogurt. 4. Rusting of iron, etc. Many a times we wonder why and how these changes take place. Actually, these changes occur because of chemical reactions. In short, chemical reaction is a process during which certain changes takes place and a new substance is formed. Let us see how are chemical reactions written. The chemical reactions are written in the form of equations. In order to understand this, we will have to first get well versed with the words reactants and products. Reactants. The substances taking part in a chemical reaction are called reactants. They are written on the left-hand side of the equation. Products. The substances formed during the reaction are called products. They are written on the right-hand side of the equation. An arrow pointing towards products is shown between the reactants and products. Let us look at this example. Reaction between carbon and oxygen to produce carbon dioxide. Carbon and oxygen combine and form carbon dioxide. Here, carbon and oxygen are reactants and carbon dioxide is product. Remember, 1. A plus sign is put between two or more reactants and two or more products. 2. Upward arrow denotes that the substance is a gas. This is how chemical reactions are written. Now, let us deal with the other important part of this chapter, that is, the type of chemical reactions. We just saw during chemical reactions, new substances are formed because of breaking of bonds in reactants and formation of new bonds in products. As a result, the atoms rearrange themselves during reactions. On the basis of this rearrangement of atoms, the chemical reactions are classified as 1. Combination reaction, 2. Decomposition or dissociation reactions, 3. Displacement reactions. Now, let us try to understand the first type of reaction, that is, combination reactions. In order to understand this better, let us try out this simple thing. Take some lumps of calcium oxide, that is quicklime, and add 50 milliliters of water to it. Touch the outside of the beaker. Students, when you touch the beaker, you will find that the beaker becomes warm. Let us have a look at this equation. We see that the reaction between calcium oxide and water produces a single compound, calcium hydroxide, and warmth of the beaker is due to energy released during reaction. So, this is how we define combination reaction. A chemical reaction in which a single compound is formed from two or more reactants is called a combination reaction. Now, let us move on to the second type of reaction, that is, decomposition reactions. Reactions in which a substance is broken down and two or more substances are obtained from it are called decomposition reactions. Let us understand through this example. When an electric current is passed through acidified water, that is, water in which a few drops of sulfuric acid are added, then water splits into hydrogen and oxygen. In this case, acidified water is the reactant and hydrogen and oxygen gas are products formed because of decomposition. Now, let us move on to the third and the last type of reaction from the lesson, that is, displacement reaction. A reaction in which one constituent displaces another constituent and separates is called a displacement reaction. The following activity can help us to understand it better. Take a few pieces of zinc in a test tube and add diluted hydrochloric acid to it. Students, you can see gas coming out from the test tube. Here, zinc displaces hydrogen from hydrochloric acid. There are various other concepts that are closely related to it, so let us deal with them. Oxidation and reduction are two such concepts. Oxidation, a chemical reaction in which oxygen combines with an element or a compound, or a reaction in which hydrogen is lost from a compound, is called an oxidation reaction. Here, carbon combines with oxygen to form carbon dioxide. Reduction. Reduction is just the opposite of oxidation. Reduction reaction is a chemical reaction in which hydrogen combines with an element or compound, or a reaction in which oxygen is lost from a compound. So, it is a reduction reaction. Here, hydrogen combines with chlorine to form hydrochloric acid. Now, let us study the speed of chemical reactions. All the changes that happen in our surroundings do not occur at the same pace. Some happen quickly. Example, when washing soda is mixed with lime juice, carbon dioxide bubbles out at once, whereas some happen slowly. Example, rusting of iron. So, let us see the various factors on which the speed of chemical reaction depends. Speed of chemical reactions depends on 1. Size of the reactant particles. Smaller the size of particles of reactants, faster the reaction. 2. Temperature of the reactant particles. Rise in temperature increases the speed of reaction. 3. Concentration. Higher the concentration of reactants, chemical reactions occur at a faster rate. 4. Presence or absence of catalyst. A catalyst is a substance which does not take part in a chemical reaction, but by its presence speeds up a chemical reaction. Example, manganese dioxide in preparation of oxygen. Rene nickel acts as a catalyst in the reduction of vegetable oil to hydrogenated oil. During some reactions, energy is given out. Example, combination reaction of quicklime and water forming calcium hydroxide and giving out energy. Whereas, during some reactions, energy is absorbed. Let us try this for understanding the concept. Take a 4 cm long magnesium ribbon. Hold one end in a pair of tongs and light the other end. We can observe it burns, giving out a brilliant white light, and white ash remains. Let us see why and how this happens. Here, magnesium burns in air combining with oxygen and forms white powdery magnesium oxide, giving out energy. Such kind of reaction is called exothermic reaction. Now, let us learn about exothermic and endothermic reactions. Exothermic reaction. Exothermic reaction is a reaction during which heat is given out. Endothermic reaction. Endothermic reaction is a reaction during which heat is absorbed. Example, the temperature of water falls down when salt is added to it. That is, heat is absorbed. Let us try this. 1. Take water in a test tube. 2. Feel the test tube to get an idea of its temperature. 3. Note down the temperature. 4. Now, add some salt in it. 5. Observe the change in temperature. We can observe that the mercury level drops, that is, the temperature of water decreases after adding salt to it. So, it is an endothermic reaction. Besides these, there are some other changes that take place during a chemical reaction, like when heat is supplied. 1. Its state, that is, solid, liquid or gas, changes. 2. Its temperature rises. 3. Its color changes. 4. It gives out gas. Try this. Take 3 china crucibles. Place some sulfur in the first, coal in the second, and copper sulfate crystals in the third and heat them. We can observe that 1. Sulfur burns, its temperature rises, color changes, and sulfur dioxide gas is produced. 2. Carbon burns, its temperature rises, color changes, and carbon dioxide is given out. 3. The blue color of copper sulfate changes.